are formulas in the middle of the formula sheet on the right-hand side. You know the whole right-hand side is trig. Why not? Do more trig than one chapter. Let's do 3. So if you look at the right-hand side in the middle, there are formulas we haven't talked about, correct? Here are the addition and subtraction formulas. Okay, some are different. So we talked about the Pythagorean theorem ones. We talked about the double angle ones. Double angle ones just are double whatever the angle you're looking for. So if you're looking for 210, we look for 420, right? If you look for 360, we look for 720. These are the sum and difference, and they're very obviously weird looking. Yes? So they should kind of stick out in your mind. So sine A plus B is sine A cos B plus cos A sine B. They use the same angles. So look, the A's are in the beginning, the B's are in the beginning. So you end up having these two sines or coses or cos, cos, sine, sine with an addition or subtraction in between them and same angles. That's a huge hint. So if you see that, you have to remember, oh, there's a formula for that. So let's look at these ones. So we have sine 48, cos 17. It's supposed to be a different color. And then cos 48, sine 17. So is there any formula on the formula sheet that covers that? Sine 48, cos 17, cos 48, sine 17, minus sine in between. Which one?
Sine A minus B.
Sine A minus B, correct? So this would be A, this would be B, this would be A, this would be B. So it would equal sine A minus B. So what would A be? What do I put? 48 degrees. And then it's sine A plus or sine A minus? Minus 17. And we get what? Now we don't need an answer because it just says write each expression as a single trig function. Yeah? You guys try C. Okay, this one is cos A, cos B, sine A, sine B. Which formula does that go with a plus sign in between? Cos A minus B. Yep. So we're going to get cos A, which is 88 degrees, minus B, which is 35 degrees. And we're going to get cos of 53 degrees. Side caveat. What if I give you this? Sine 30 degrees, sine 15 degrees, go away, minus cos 30 degrees, cos 15 degrees. Give me that one. So we have sine A, sine B, minus cos A, cos B. Is that formula on our formula sheet anywhere? Sine minus cos, cos? No, but what is on it? Cos, cos minus sine, sine. So how can I get it to be like that? Take out a something. Take out a -1. If I take a -1 out, this will be negative sine, sine. This will be positive cos, cos. And does it matter the order in which they're written? No, right? This is the same as saying cos, cos minus sine, sine. Yes? Because I can move them around. They're just terms. So I could rewrite this as cos 30 degrees, cos 15 degrees, minus sine 30 degrees, sine 15 degrees. And so I'm going to get negative, what formula? Cos what? Cos A. It has a minus sign in between. What is it? So this would be negative cos 45, which would be the single trig ratio. But they could, on a test, actually take it further and go negative root 2 over 2. Right? Take over that. So just because the formulas don't look the exact same doesn't mean you can't make them look the same. Right? If it's the exact same thing throughout all of mathematics, if your terms are the exact same but wrong sign, you just take a -1 out. Poof, you fixed your problem. Yeah? Okay, this one, cos squared A, sine squared A. Where is that found on your formula sheet? Cos squared A, sine squared A. Cos 2A. Because cos squared A minus sine squared A is my first one. Right? My first double angle identity for cos. Yes? So we're going to fill in A. So our formula is cos 2A. So it's going to be cos 2 what? 2 times pi over 3. And you can put the 2 over 1 if it helps you. So it's going to be cos 2 pi over 3. What about this one? 2 sine A cos A. 2 sine A cos A. Formula on your formula sheet? Sine 2A. So we're going to get sine 2 pi over 12. So it's sine pi over 6. Now guys, I have to be honest with you. The people who do well on chapter 6 know what formulas are on the formula sheet. So you see this and you immediately know, oh, that's side 2A. Or you at least know, hey, that's on my formula sheet, right? So do you have to have your formula sheet memorized? No, it's your formula sheet. But if you do actually know what's on it, you will do 100% better. The people who know what's on their formula sheet, they see this and they recognize, oh, there's a formula on my formula sheet that matches that, right? There's a formula on my formula sheet that matches that. So the people who do well in chapter 6 know what's on their formula sheet. People who do bad are the ones who search for stuff on their formula sheet because they don't know what's on it. All right? Okay. We have to consider the expression 1 minus cos 2x sine 2x. So we're going to talk about simplify the expression. We'll do this one here first. Simplify the expression to one of 3 primary trig ratios. So I have 1 minus cos 2x over sine 2x. It's Friday. We won't talk about the MPVs today. What can I switch out? I'm trying to get it to one primary trig ratio. The primary trig ratios are sine, cos, and tan. So this should switch to sine, cos, or tan. That's what it's telling me. So what can I switch out? I can switch the cos 2x out. You can't switch that to tan. You can't. Some people are like, oh, can I just make this be cotan? This is 1 minus cos 2x. If it was cos 2x over sine 2x, yeah, you can make that be tan 2x. But it's not that. It's 1 minus. So I cannot do that. When I see a cos 2x, I say, okay, I'm leaving that one till last because there's 3 options for that one, correct? But the sine 2x, there's only 1 option, so I switch that one out first. So I'm going to go 1 minus something. So I'm going to switch that out in a few seconds here. And then I'm going to get 2 sine x cos x. Because that way I don't have any options. It's 1. I'm going to switch it. We agree? I need this to work out to be a single trig ratio, not 1 plus a single trig ratio. Yeah? So that 1 is actually a problem. I need that 1 to get out of my life in the top. So I'm going to go look at the cos 2x formulas, that when I replace them, I'll get a minus 1, and then the 1s will cancel. Okay? So if I look at the very first top cos 2x formula, it's cos squared minus sine squared. That just makes it worse, right? That doesn't make it better. If I put this one in, the 2 cos squared x minus 1. If I put this one in, I'm going to distribute that minus sign through, and I'm going to actually get a plus 1. So is that helpful? No. And if I put in the 1 minus 2 sine squared x, will I get a minus 1? Yep, so it's going to be this one. If I put this one in, people think, oh, it's a minus 1, they'll cancel. Well, you're distributing that minus sign in, so that'll actually become a plus 1, so the second one's no good. We have to go to the third one. 1 minus 2 sine squared x. So how do people mess this one up? They don't put this in brackets. You see how I had to put that in brackets? Because I'm replacing this whole thing with this whole thing, right? So it has to go in brackets and distribute. Do you see how that could be an error where you forget to put the brackets? And then you won't make it be a positive 2 sine squared x? Do you think the answer will be there if you forget to distribute? It'll absolutely be there. So I have to pick more than the correct one. So I'm going to get 1 minus 1 plus 2 sine squared x over 2 sine x cos x. The 1's cancel, so I'm left with 2 sine squared x over 2 sine x cos x. And what can happen? Yeah, the 2's cancel. The sine squared x is just like writing sine x times sine x, right? I could cross that 2 off and just write it out twice, could I not? Same thing? Same? What's sine x over cos x? Tan x, and I'm done. Just so you know, we'll be done this unit at the beginning of next week. We'll move on to chapter 5. No longer is the whole month takes a month to do a unit that left in grade 10. Here's a week, and we're done. Okay, cool. Okay, I want you guys to try this one. I don't want the non-permissible values. I just want you to simplify it. We're talking about non-permissible values, not on a Friday. That's for another day. So the first thing we do is write out the question. Some of you guys will go and just like start changing it already. You have to write out the question first. Then you change it. Sine 2x is 2 sine x cos x. Sometimes it's actually easier for people to solve these if they do this. Because that's a 2 times a sine times a cos. We agree? Ultimately? So you can either show that things are multiplied by putting nothing between them. That shows they're multiplied. By putting dots between them, shows they're multiplied. By putting multiplication symbols between them. Or brackets. Those all mean multiplication. Correct? Okay, on the bottom, I need to get this plus 1 to go away. So I need a minus 1. And there's no distribution on this one. There's no negative 1 in front of this cos 2x. So I go straight up to the formula. And the only one that has a minus 1 is 2 cos squared x minus 1. So I get 2 cos squared x minus 1. And then I have to add, that's for this. And then I plus 1. And then these are gone. So I have 2 sine x cos x over 2 cos x, technically, if I so choose. Because cos squared x is just the same thing. Gone, and I'm left with 10. But there were non-permissible values, because see I have cos x in the bottom, I would have to say where cos x can't equal 0, and I'd have my non-permissible values. This one in the bottom, I had sine and cos, so I'd have to say where sine and cos are not equal to 0, which is awesome, because it's every single 90. Every arm is where sine and cos can't be 0. That's just a glimpse into it, but we'll actually write them out on Monday. I don't want to use your brains for NPVs today. You know, the little things, right? Okay, next page. All right. So star these ones, because everyone forgets about them. So we're starring these ones. So on your unit exam, I'll ask you for exact values of trig ratios. And when I ask for exact values of trig ratios, I'm asking you to go to your unit circle, yes? So you can give me like sine 45, or cos 225, or cotan of 225, or sine of 15, or cosecant of 15, or 315, or secant of 315. Those are all fine. Go to your unit circle, you flip, you use formulas, yes? But what happens if I ask you for exact values? This is a huge thing here. The exact value for this. Well, first off, put sine pi over 12 into your calculator and get the not exact value, which is what everyone gives me on the test. I go press the sine button, I slap my hand, and I say I need to be in radian mode. So what is sine pi over 12 equal to? 0.25 blah, 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 blah. Yes? What happens if you give me that answer? 0. Is that, boys, is that an exact value? It's exactly not an exact value, actually. It's the exact opposite of an exact value. Exact values are fractions, or terminating decimals, or repeating decimals that you can turn into a fraction, therefore the fraction is the answer. Yes? But non-repeating, non-terminating decimals are the exact opposite of an exact solution. They're exactly what I do not want. Okay? But when I get my exact solution, can I convert it to a decimal and double check that I'm right? Yeah, so getting that decimal isn't the end of the world, but do not box it. It is not an exact value. What is pi over 12 as a degree? How do we convert it? Pi divided by 12. Oops. What am I going to times by? I need 180 on the top because I need the degree symbol, correct? Divided by pi. Okay. What's 180 divided by 12? 15 degrees. Is 15 degrees on my unit circle? Yes. Every degree is on my unit circle. That's what you should say to me. Is 15 degrees an exact value on my unit circle? No. So the question of is 15 degrees on my unit circle? Yes, it is. Cos 15, sine 15. Give me some decimals. Boom. It's on my unit circle, right? But is its exact values on the unit circle? No. But are there any numbers on my unit circle that have exact values that I could do some mathematics to that would get me 15? What? What could I do? 2 numbers. Could do some mathematics, perhaps subtraction. That could get me 15. The difference between 45 and 30. What's 45 minus 30? 15. Do I have sum and difference formulas on my formula sheet? Oh, I absolutely do. I do. Let's try it out. So, can I write 45 minus 30 when it's in radians? No. Can I write its best friends, the radians of those? Can I convert this to degrees so it makes sense to me? Yeah. You just have to write the stuff in radians. Okay? So I'm going to go sine 45, which is pi over 4, minus pi over 6. We agree? Could I have went 60 minus 45? Pi over 3 minus pi over 4? Yep. Could I have went, I need 15. Could I have went 150 minus 130? 5? Those are my unit circle. That would give me 15. I can pick any of them, right? Then the common error happens. The lovely distribution. You guys go sine pi over 4 minus sine pi over 6. That is not a real thing. That is illegal in all states, territories, and the answer to that will be on your test, and it's wrong. You have to stop yourself. You have to slap your hand and be like, I am not allowed to distribute. There is a formula on my formula sheet that I have to use. That is that. Yes? So if you know you're someone who's going to distribute, which I would say is 95% of you, until you finally wean yourself off of trying to distribute, put a star here and say, do not distribute. Cannot distribute. That is wrong. If you don't believe me, watch this. Sine pi over 4 minus sine pi over 6. Type it in your calculator. Sine pi over 4 minus sine pi over 6. Okay. Oh, it's the other one. Oh, they're still there. Hi. Great. It's not my birthday. Stop doing that call. Shitty job. Shitty. Oh gosh, that's right. Okay, what do we get for a decimal for this? Turn around, McCullough. What do we get for a decimal? 0 point, pardon? Oh wow, that's so the same answer. Except it's not. Because you can't do that. Because distributing is wrong. United States territories, Mars, and unknown clouds. Okay? No, all over the place. Okay. So that should be a hint that we're wrong, because we can check, right? We can check our decimals and our exact values in. Secondly, I would go root 2 over 2 minus half, and then it also would give you that decimal, which doesn't match. Okay? But there's a formula on my formula sheet. This is A. This is B. So I write the formula below to help me out. I need sine A minus B. So sine A minus B equals sine A cos B minus cos A sine B. Right? That's just the formula off your formula sheet. This be A, this be B. Yeah? So we plug it in. Sine pi over 4 cos pi over 6. And some people say, well, do I just take the minus sign with? No, you don't take the minus sign with. This is a minus sign. Do you see the minus sign? These match. So this minus sign goes with this minus sign. So this is A, this is B, this is minus sign. Yes? So your A is pi over 4, your B is pi over 6, not negative pi over 6. Do you agree? Minus cos pi over 4, sine pi over 6. Okay, I remembered it. Okay, so what is sine of pi over 4 now? We need exact values. Square root 2 over 2. What is cos of pi over 6? Root 3 over 2. Minus cos of pi over 4. Root 2 over 2. Sine of pi over 6. 1/2. And so I get root 2 times root 3, grade 10 and grade 11. What happens when I multiply radicals? Coefficient times coefficient, radicand times radicand. What's in front by what's in front, what's underneath by what's underneath. Correct? So nothing's in front, so nothing's going to stay in front. Root 2 times root 3 is root 6 over 4 minus root 2 times 1, root 2 over 4. The great thing is you always have a common denominator. You just write root 6 minus root 2 over 4. And before I box it, I'm going to type that into my calculator and make sure that gives me 0.2588 blah, 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 blah. But not write that, because that's not an exact value. And you would have went from perfection to blah. You box that. Same decimal? Oh, here's the exact value. So this is the exact value to this garbage. That is not, it's not garbage, but you know, it's not an exact value, so it's garbage. Does that make sense? Okay, cos 165. What can we use to make 165? Look at your unit circle. What numbers can we use? Yeah? 135 plus 30. There's lots of options. We can use that one, though. So we can go cos 135 plus 30. In this case, it doesn't matter if you go 30 plus 135 or 135 plus 30. You'll get the same thing. Subtraction, you have to watch yourself, right? Because you have to subtract the appropriate ones. Before I even do the question, though, I find the not exact value of cos 165 so that when I'm done, I confirm that I'm actually right. And you should never have to know if you're wrong or right on these questions. Because you put cos 165 in your calculator. When you go to press cos, slap your hand, what do you need to be in? Degree mode. So you got to change your mode because you were in radian class. Try this one out. So we have cos 135. Cos 165, what is that as a decimal? 0 decimal. Negative 0.96593. Why is it negative? Why is it negative? It's in quadrant 2 and it's a cos, and cos is negative in quadrant 2. Yes, because cos is x, and in quadrant 2 all x's are negative, so it makes sense. All right. So then we use our formula. It's our A, this is our B. Our formula is cos A plus B equals cos A cos B minus sine A sine B. So we're going to get, oh, I have the equal sign on this side, that's just dumb. So we're going to get cos 135 degrees plus 30 degrees equals cos 135 degrees cos 30 degrees minus sine 135 degrees sine 30. So do you see how chapter 4 is extremely important? Because if you can't find sine 135 and cos 135 and sine 30 and cos 30, you can't do this question, right? That was basic questions off of chapter 4. All right. Cos 135 is negative. Yeah, keep going. Root 2 over 2. Cos of 30 is root 3 over 2. Minus sine of 135 is just root 2 over 2. And sine of 30 is 1/2. And so I get negative root 6 over 4 minus root 2 over 4. And I get negative root 6 minus root 2 all over 4. I punch it into my calculator, and it's miraculously the same answer. I feel confident in myself, and I move on. Yeah? For Monday, I want you guys to have these two done. Tan. Tan has a lovely formula that it has a fraction. It's a fraction formula. Enjoy. You're welcome. It's okay. Can you do one thing for me? I'm going to give you a little hint. Tan of 60. What is tan of 60? Sine 60 divided by cos 60. We agree? We're going to write this at the bottom of the page. What is sine of 60? Root 3 over 2. And cos of 60? So tan of 60 is root 3. Is that a fraction? No. So would you end up with a fraction in a fraction? Because tan 2 theta is a fraction, right? So tan of 60, not too bad. I know you're like root 3 sucks, but just wait. What's tan of 30? Tan of 30 is that flipped, just so you know, because it's what? Sine of 30 over cos of 30. What's sine of 30? 1/2. And cos of 30? 3 over 2. Your denominators cancel, so it's left with 1 over root 3, which rationalized is root 3 over 3. Now would I end up with a fraction embedded in a fraction? Yeah. So when in doubt, when I'm doing tan 105 or tan 11 pi over 12, I'm going to try and use tan 60 as much as I possibly can, or tan 60 reference angles, so that I end up with root 3's in my fraction rather than root 3 over 3 in my fraction. So what would tan 105, what would be a good one to use? 60 and 45, right? There are other ones that you can get away with using 30s as well, subtraction wise, but try and use tan 60s when possible, because tan 30s are not nice. So try these two out for Monday.